All right. Hey, everyone, and welcome to another talk of GoLab 2020. Today we have a special talk by Ellie. Her talk is about network services with HTTP and WebSockets. So I'm going to bring Ellie on live so that we can all hear a little bit about this, and then we'll go ahead and play the video. So let's bring Ellie back on. There you are. Hello, Ellie, and welcome.
Good afternoon.
Yes, good afternoon to you too. Would you like to give a short introduction or abstract about what you'll be talking about in the video?
Yeah, so I normally do these insanely fast-paced talks about code. This is a somewhat slower-paced talk about code because apparently I haven't figured out video yet, and I accidentally wrote a workshop. So I'm going to drop everybody into the final third of the workshop, which is actually the actual topic that the talk is about: WebSockets and Go. But there's also two other sections that go with this, which GoLab have all three of them, so you can watch all three of them later, that go from the very beginnings of the simplest HTTP program you can write in Go, all the way through Ajax and then into WebSockets. So if the start of this seems a little bit scary, I apologize. It does assume you've actually worked your way through 14 examples and an hour of video. Anyway, I hope it will be interesting. I do a lot of work myself with WebSockets, admittedly mostly in Ruby with Sinatra. So this is the first time I've put everything together for just Go. So it will be an interesting takeaway, I hope, for people. And by the end of it, if anybody is inspired to go and do the same thing, I'll be very happy, because I'd love to see people using WebSockets more and Ajax and things like that less. So anyway, go on.
Fantastic. Thank you. All right. So we'll go ahead and watch the video in just a moment. Oh, one thing before we go and watch the video, everyone, please, if you have questions, which you might, go ahead and direct those questions to Ellie through the Q&A chat. So you'll see the two different buttons, the room chat, which you can say hi to everyone in, and then the Q&A chat. Can you direct your questions there for her at the end? That way we can just keep everything organized. All right. Thanks so much. Enjoy and stay tuned until the end for the live Q&A. Thanks.
Good afternoon, and welcome to one in a series of 3 talks recorded for GoLab 2020 on the subject of network services and HTTP programming in Go. In this third talk, we're going to explore HTML5 WebSockets. HTML5 WebSockets, a technology nobody seems to be using, except buried away in things like Backbone, but which is actually really very, very handy once you get used to it. So let's give it a that. All right, this next example, we're going to slowly introduce WebSocket functionality to what we already had. So we've already got this effectively a messaging system now. It was a guest book, but now it's a messaging system. And we're going to move from that all being done with Ajax polling and therefore putting a heavy load on our server to being done actually by a WebSocket or two, handling the data and doing the interactions that way. We'll end up with a program that won't actually have any Ajax calls in the digital. It'll be a single page JavaScript web application. So, right. Firstly, in the previous example, I didn't actually mention the fact that I had set up this set of things called pigeonholes. Pigeonholes are just a slice of messages. The first element there, pigeonhole 0, is our public messaging channel, and everything after that is our user messaging channels. Right. And we put them as a whole slice of them in this variable p that we're going to use for holding on to them. We've got a few other things going on, probably aren't that interesting here. There's a big concept I've introduced though. If I go right the way down to the bottom, I've introduced a concept of a monitor. Now what a monitor is it's just another web handler, only this web handler happens to create a web handler that whenever it sees an event, which is whenever something passes through it, whenever it's invoked, before it actually does its payload, i.e. calls the function that it gets as a parameter, it'll send off a copy of the string version of the current URL for this particular request on a channel C there, which actually we pass in from up here an events channel. And I've made it 4096 items long, not because it really needs to be, but just because it's easy to think in terms of 4096 blocks at a time. It should be amply sized to buffer not only the number of events that you think you'll generate, but a few times that amount, so that you've got spare capacity so that the channel never holds. Because if the channel gets full, then obviously requests are going to wait for that channel to start clearing before they're going to complete their round trips. And you could end up with a rather overloaded server that way, so you don't want that. But anyway, because of the way we've defined monitor, you can see that now for each of our main web routes, instead of just serving content, we can monitor the fact that we're serving content. And this is a very nice, simple example of how to do middleware. It happens to be a nice one because it also generates this real-time feed that is going to be a nightmare to deal with. So apart from that, our pages are all pretty much doing the same things as they were. To call them pages seems a bit weird because, I mean, they're apart from the actual HTML that's served and the JavaScript that's served, they're not pages, they're virtual. And there's nothing really else to talk about there. What there is, though, is this down here, these two bits. Firstly, we've got an array of monitors. Every time that somebody wants to pay attention to our event feed, we create a monitor for paying attention to the event feed, and we're going to pump events down that particular channel as they're needed. And then we've got the actual WebSocket handler. Now this, you'll notice it's a handle rather than a handle func. And nearly everything I do with web servers, I do with handle funcs. I don't normally do it this way, but with the WebSocket you do, because you're not actually dealing with a web request in the same way that needs to write a response. You've now got a genuine socket. It's a TCP socket. We're going to talk backwards and forwards in raw frames. You know, this is hi, I'm going to write a MUD and I'm going to put it in my web browser sort of territory. And there's not a lot that has to go on in that. When we connect, we create a new monitor, so we append it on the list, and that just consists of taking the WebSocket handle and sticking it on the list. And this here is, this line of code makes me feel so bad, and so, but at the same time I kind of like it, because the WebSocket is actually an IO reader. I can use IOUtil to just basically sit there and say, right, read all of it. Just sit there until an end of file, and then I don't have to write any code for handling end of file. I can just say, fine, sit there, read from the WebSocket until the WebSocket closes. When this actually happens, now this is slightly redundant, this defer, because actually it will generate an error, because actually by the time the defer gets called, it's after the read all is already finished. Doing a close on the socket at that point is probably redundant. The socket is probably already closed. I don't know if there's any edge cases where it isn't. If there are, and we try and close again, we're just going to get something out, but I don't know what. But anyway, so this bit of code will just sit there. That pattern, though, of closing the WebSocket when you finish running the handler, that is a good one to get in the habit of. Just like everything else in Go, do your cleanup as soon as you finish doing things. Okay, so that's the relatively simple side, is actually the Go side. The one other thing to mention, of course, is that we do have an event loop. We have this separate Go routine that's sat off in the background, and it is listening on that events channel, and it's broadcasting those events to each of the monitors that it knows about and each of them it's sending that event wrapped up as a JSON message so that they can just say it off the other side. I've also given a default behavior whereby if there isn't an event, it can instead wait for a millisecond. So that slows down the amount that it has to do on the server. And I could make that 10 milliseconds, 100 milliseconds, depending on how fast my event stream was. If my event stream is producing 100 events per millisecond, then I don't want that default case to be like that at all. That would be a nightmare. But in our case, it's not, so it's fine. The HTML is largely unchanged. I've introduced an idea that we've only got 3 items that can display at a time in any one of the categories. Think of it as a rotating buffer, and we'll have some JavaScript that covers that. I probably won't discuss it. It does what it does. It's JavaScript. But if we do go into the JavaScript, we've got some stuff that's actually quite interesting. So you'll notice that as we come down here, we've still got the Ajax stuff in because we're mostly using Ajax to drive the interface still. And that's all stuff we've seen. There's nothing really interesting there. But if we come down a little bit further, right, firstly, we've got yet more Ajax calls going on to get an updated number of events that have been seen by the server. And it's the easiest way to plumb that in at this stage. But then as we go down further, we're now setting up a WebSocket. And this bit of code is deliberately overly verbose. The only actual meaningful handler that I'm setting is the onMessage, which will actually do some work whenever a message is received on the socket. The other 3 I've left in there just so you can see that they exist. On open, we will find a use for later. On close is just if you need to do some cleanup after the socket has finished doing its job. And on error is whenever you get an error, you can then log that, and that's kind of handy. We create an instance of this server socket, and I'm not doing anything clever here to simplify addresses. I could have templated this, I guess, or something. But we just open up a WebSocket on that one particular URL. And then we're going to update the buffer with however many items come in for the event list. Every time there's a message, that message is actually giving us another event off the server, and we're just going to run them. And then I've got the final bit here. We've got to actually do a bit of work when we load the window, and that's because I've decided that my client now registers with the server, which does some setup. So if we go back over here and have a look, where we've got register up here, just creates a pigeonhole. It creates a message box for the client and gives the client back an ID. And you'll notice that my Ajax response, I pass that, and that's my client ID. So now I'm getting the ID backwards and forwards that way. So let's run that and see how that goes. Right, let's connect up the first one. Oh, you can see it's already going mad with the events. In fact, it will keep going mad with the events because I've got nothing to prevent it from asking for a message that doesn't exist yet. And in fact, that would be the first thing you would rate limit if you were turning this into something significant. I've done that again. We open the last close window. Right, and then come over here. That one's off doing its thing. This one is now a completely different session than the one it was previously. There's no fallback here. This code is not designed to be safe to run in the wild. It's purely designed to show off concept. So let's send number 4 a message. The boring old traditional hello. And there you see that the private message turns up. I think number 4 should probably send everybody a message. See, boom, and they fill in. Now you'll notice that there's always a lag with the messages turning up, because we have to wait until the timer goes off to go and ask for a message. And you'll also notice that the server log is building up insanely. And look, the server log is being generated in real time by the socket. It's not leaving any evidence there at all. It's got no connection implications at all. But you'll also notice that, of course, all of the other things are all still giving lots and lots and lots and lots and lots and lots and lots of messages. So, all right, let's kill that. I think I've belaboured that one enough. Let's clear those. Now, let's have a look at the next one along. So, all right, I think our HTML is unchanged, so that's not very exciting. I'll shut that. We've got a lot more going on in this example. So, firstly, let's go down and see what we've got. So we've still got our registration going on. I've beefed up what registration now does. It doesn't just create a pigeonhole. It now also creates a monitor slot to go with that pigeonhole. Monitors 0, the first element in that slice of monitors, that's always going to be null. That is not a monitor that you can write to. Because of that, and to simplify some other code, somewhere down here, when I'm actually handling them, I check to make sure they're not nil. Now, the alternative I could do there is, instead of that, I could actually do it on a slice indexed from 1. Either of them works fine. But it's best practice to actually make sure that they're not nil, just in case any of them become nil at runtime, and you get a socket error. So what else have we got going on in here? It's now here, actually in the handler for registration, that I'm doing my IOUtil read all. But I'm not doing that as the first thing. Before I do that, I'm actually sending my WebSocket the JSON data for the client ID. So the client ID is coming down at the time that I actually do registration. I've no longer got this separate call to establish a monitor. It's all handled as part of registration. And you'll notice I've no longer got a separate call for telling me the number of messages. And we'll get into why in a second when we look in JavaScript. But the rest of this is pretty similar. So we'll leave that there. If we go over into the... Right, let's go into the JavaScript. All right. We've still got a couple of AJAX calls that go on. One is to read a public message and one's to read a private message. You'll notice that we've got this pair of counters here, public seen and public total. And public seen increases each time I see something, whereas public total gets increased by other means. I'll come back to that in a second. Because if we now look down here, this is our WebSocket that we've got here, our server socket. The setup for it is now simplified. I've taken it out of the stuff that we don't really need to know about. I'm still keeping the logging to console if we need it. I get, as the very first thing I do when I connect, the very first message that comes in will find out what the client ID that I use is, so that I can establish my client ID. And it's also going to get a public total, a private total, and an events total. So that I already know when I first connect how many things there are that I need to catch up on. And so I can record that straight away. I don't need any messages coming in beyond this to tell me that. The next thing I'm going to do is a little bit sneaky. I'm not sure it's actually safe to do it, but I'm going to do it anyway. And I'm going to replace the message handler. So I've got this message handler up here just to do my handshake, effectively, give me my client ID. And then for every other message after that, I'm actually going to give it this new function. And what I'm going to do here is I'm going to pass whatever comes in. And I've just basically defined a binary, an array format that's got various bits of information in. So the very first element in the array is how many total events have been seen by the server. The second item is what is the event, what is the actual event that I've just seen. And then after that, we've got the third and the fourth items coming in. What's the total number of public messages broadcasts that have been received so far? And what's the total number of private? So now I can drive my decision to pull stuff from the server with AJAX from this message loop. And that's all happening over a socket. So it only gets communication when the server wants to send me messages, rather than my constantly hitting and saying, please, can you give me? Please, can you give me? Please, can you give me? So let's watch this in action. Right, 17.co. So there we are. You'll notice the server event log does update when events come in. It only picks up events after they've happened, or rather as they happen. It doesn't look at historic events. So the first feed didn't show me events 0, 1 and 2 because it never saw them. They'd already been dealt with before the server starts sending out events. Now, I could have written that differently so that it sent out every single event, and that would mean I'd have to keep buffering all of those events forever. The event feed is intended to be real-time data that I'm only interested in if it comes to me now once I'm listening. Whereas the messaging isn't like that. Messaging is these things are persistent. I want to pick them up no matter what. So right, let's send a public message of hello world. Right, now you notice everybody gets hello world. They still get it with a lag because they're still dependent on when their timer kicks in to ask for it. But they only ask for it when they need it. Look down here. See, I've not sent a lot of traffic. If we come here to source, you can actually see it a little bit better. Look, no traffic going out there. And if I bring this one up, even less stuff. You know, I've got my registered WebSocket, obviously, but not a lot else. So let's send a private message just to prove our private messaging is still working. Hello 3. 3 gets their private. We all see the server events happening though, but we've now got a much quieter server, much quieter interaction. Okay, we can kill that off and move on to the PS de resistance. The final example is an excellent example, but also it doesn't quite work. It does work enough to show you it works, but I wasn't going to spend another week pulling my hair out. I'm already 4 days late recording this because it's Friday afternoon, not Monday. And I think people get a bit tetchy if they had to wait until Saturday or Sunday to get any video. So we've got this all set up to do its thing. All right, let's close that. If we now pull up number 18, yeah, still with the boring HTML. Okay, so yet again, we've done a bit of tidying up. This example only serves 3 routes, right? One route is to get the HTML page, one is to get the JavaScript page, and one route is to actually register a socket. Everything else that happens is going to happen over that WebSocket. The whole interface is going to be driven interactively by the WebSocket. JavaScript is going to make sure it pastes up into the HTML what should be in the right places in the HTML. We've essentially managed to get ourselves from through an awful lot of technology and a very heavyweight browser environment back to where we were with IBM intelligent terminals in the 1960s, with actually being able to do markup. And it's kind of a testament to just how bloody minded programmers can be that we've gotten here. Now, if we look in our JavaScript, the first thing to notice is I've gotten rid of all the Ajax code. There's none. There's no Ajax. There's no timers being set on anything. There's nothing that's going to poll. It's all just going to sit and sort of receive responses as and when. Down here in setting up the socket, I'm actually doing that on page load because I think probably it should happen on page load. It's belt and braces sort of territory. It probably could happen before without having a window on load event trigger, but what the heck. We've already seen that the first chunk of code is just the handshake, gets us the basic information we want to start with. I've stripped out the event stream because quite frankly, that was just there to show you the difference in load that you get between the two approaches. But what I've got here is I still want to know how many events have happened. So my actual handling function for a WebSocket message coming in, it wants to check for one of three things: a status report, which will either give me an updated event count or an updated list of public messages count or private messages count. In other words, that status report tells me there's some other event happened that's significant, and I should update my interface with the appropriate metadata. It might be instead that my message is a broadcast message, in which case, if it's a broadcast message, then I want to update my actual list of public messages received, and likewise for private. The console log statements really are in there just for debugging, because at some point I plan to figure out exactly why I'm getting the bug I'm getting, but I'm just not today. So if we now go and we look in our Go code, our Go code is somewhat more heavyweight now because it's got to do socket handling. So firstly, I've decided to take the idea of a pigeonhole and extend it. A pigeonhole is now the combination of a WebSocket, a list of messages, and a cursor in that list, so I can step through and know how far I've stepped through. I've got a set of these that I call pigeonholes together collectively, and it's got a tick method. That tick method takes a duration for a timer, and it will quite happily sleep for that amount of time. Now, this isn't really where the sleep should happen. This is intended to be running the Go routine and just to take care of making the Go routine sleep. It's a slight crossing of responsibilities, but decisions. The very first thing I want to do is go through all the public messages. Whenever a tick happens, I want to check all the public messages. If there's any public messages, I send them straight down on my web connection, right, which is now this thing, ph.con. You'll notice I haven't bothered giving it a name because I'm perfectly happy just dropping it in as a, you know. If I could put a slice of messages in there, without having to actually give it a name, I would. And the reason I gave cursor a name is because just calling that int wouldn't be very clear in code. But I could have a cursor type, I guess, if there was something more complicated I wanted to do. Once I've sent down all of the public messages that have been seen, I update the cursor for public messages. Right? And then I find the private messages for each mailbox and I send them out. Now this is something I could put off in a separate Go routine. I could do a separate Go routine for each one, and probably should. This would be a bottleneck on your average server. Down here we've still got an event stream because we still want to keep track of events, but most of our heavy lifting is happening in register. You'll notice our register method here is horrible, and if I had an extra day I would abstract this out in some lovely, clean and wonderful fashion that everybody would go, oh, that's just nice, but I'm not going to do that. So if we look here, first things first, I do my setup. So my ID is just whatever the length of the pigeonholes is. I get the next pigeonhole slot. I've got a ticker that I'm going to use so that I send out status messages on a regular basis. And I'm going to send out status messages every second because they're not that urgent. It's nice to have them. They can be useful for updating you and saying, well, you should slurp another pile of messages now. But I don't really want to make them a key thing because that's not the model that we're using anymore in our interaction. But I do want them to come down relatively reasonably. Technically speaking, about 0.7 of a second is how often you should update something in the user interface for the user to think that it's in real time. 1 second or longer is kind of too laggy. Less than half a second and you're doing it too often for people to care. Now, down here, if an event has happened, then I'm going to update the event data and I'm going to send out a status message as well. So if events don't happen for ages, but something else happens in my code. It won't in this because this example isn't complicated enough. But if something else was happening, I'd still have my timed background status messages going out and going out to everybody. And then finally, my default activity is just to generate another event. This is a bad idea, by the way. It's just there to show you can have a default and you can do something. And when I generate that event, I shouldn't be. But the important bit is the following thing, that I then go off and I do a tick and I set a 100 millisecond timer. 100 millisecond sleep, and each time through this, most times through this, it's going to go to the default because there's not going to be an event waiting and there's not going to be the ticker going off. So I'll send out about 10 times a second. I'll try and send out all the messages I've got, and that's perfectly fine for a small number of clients. In the real world, you do something more complicated. All right, now that's all going to go and run in the background. That's our message handling loop, our event loop for actually deciding what to send. But at the same time, we also want to do a whole pile of receives, and I've made the receive the foreground loop. I could have done it the other way around, to be honest. One has to be background, one has to be foreground. Think of doing a join in threads, for example. The thing that you've got here is what's effectively doing the join to hold everything together, time-wise. Every time I get a message in, I'm going to generate an event to say I've received a message, because that's kind of nice. And then I'm going to append that message onto my list of messages for the appropriate recipient. Now, I might want to have a more complicated protocol than that. I might want to send through different kinds of commands that can do different things. I've decided not to. The first thing you could do is sort of like say, well, it's like IRC. I can have some slash commands or whatever, and for other purposes, but we're not going to do that. So we've got all of that going there. I don't think we've got anything. Yeah, the only thing we've got additional is we've got this function I've introduced, sendJSON. SendJSON is just a way of conveniently taking a random selection of things that I will want to stick into an array, and then I want to serialize into JSON format and send down the WebSocket. And it's a convenience wrapper. So that's everything seen. Let's run it. Let's see how it works. So, okie dokes, background here. You'll notice we have events going mad. Well, of course we've got events going mad because we've got a 100 millisecond timer going away, effectively, because we pause every 100 milliseconds after we've done a tick. And that event count, they're not in sync in the three things, you'll notice, but they're all roughly in the same ballpark, and they go fast. And look, there is no server traffic being generated at all in the way of web requests. It's all being done as individual frames going backwards and forwards to a TCP connection, chunked according to JSON messages. So let's send a public message. Now, I did say it was buggy. I've got something going on that means that it gets a little bit excitable at times and sends a message multiple times down any one stream. It's probably a race condition, because I haven't really done a lot to make this code thread safe. In a real world server, you would spend a lot of time making sure that everything was thread safe. There would be mutexes all over the place. I did have versions in development that had mutexes, but then I've got to talk about mutexes, so we're not going to talk about mutexes. So let's say I want to send something to number 2. This is also why I've got this buffered output format, so that we can get away with having something get too many messages. If I want to send to number 2, who are you? And we'll submit that. And you'll notice they get a message from us, but the private messages count hasn't updated correctly. So that's related to whatever the bug is. And then they might want to send back to number 1. I'm 2. And then if we kill this down here, we get the message back. So there's bugs in this bit of code that need sorting out, and they're obtuse bugs that I was up very late last night thinking about and decided that it didn't actually affect this being a good demo, which is not like me. I don't normally like bugs. My business partner goes a little bit nuts about my getting rid of bugs, because quite a lot of times they're bugs we could live with, which is an odd way to look at it, but I used to work on aviation software many years ago. We had this insane target of 1 in 3,000 lines of code was buggy. I don't believe anybody ever really hit that. But anyway, so up until now, all of this has gotten us to the point where we've got a web server that mostly doesn't respond to web requests. It's mostly doing everything using a TCP socket, which means that this can now tunnel arbitrary number of TCP sockets through port 80 or port 443 if we want a secure connection. And both of those are quite nice in their own right, because it means that we can write stuff that's going to play with client software. So for the very final piece of code, which does require me to actually have a copy of that server running in the background, right, the final piece of code is a command line client that's going to connect to the web server, and it's going to slurp down information just the same way that a browser session would, only now it's going to use Go to decide what to do with it and print it out. And yet again, we're still using JSON as our cross format and all of that. There we are. So for this, I was expecting this to be quite difficult, but actually I put this together in about 20 minutes this morning. It's actually, this one was, it doesn't do anything exciting, so I mean, it's not like that's a great achievement, but I was just expecting to get sucked into a lot more, oh my God, along the way. So we'll open up a separate session there. And now if we go round, we will open a browser session or two. And then over here in our new session, we will run our new sample. Right, now it's connected as user 3, because the very first thing that it will do, if we look here, the very first thing it does is exactly what our JavaScript does, reads its user ID. So we know that we're on mailbox 3. We know that we want to keep track of event counts and public and private counts so that we know whether or not we should be checking for new messages. And then down here, I mean, if I could transcribe this code letter for letter into the JavaScript, you know, just with the few changes you need because it's JavaScript, not because of the structure or anything. And here I'm going to print out broadcast messages, private messages, and status requests as and when they happen. So let's go back around to our web browsers. Let's bring this one in a bit. I don't really care about that one. So let's start by writing our broadcast message. Submit that there. Right, we've got a status update that tells us we've got a broadcast. And then we've printed that broadcast 3 times. It's clearly deciding to do something very strange at that point, but we've got a broadcast come through. Now we're user number 3. So as user number 3, I should be able to send user number 3 a message, which then goes a little bit barking mad. But if we take that all back, you'll notice we did successfully get our private message through. Now, the reason we're getting so many status updates is because the server side is going, I must give you so many status updates. And that's where we have to fix the bug that's actually in the server. Not for today. But as you can see, we have, over the course of 19 examples, gone from the most dumb-headed web page all the way through to a command line text client talking to a web server in real time over effectively a TCP socket without ever having to write a line of TCP code, which, trust me, is a good thing. Thank you for listening to this third and final episode in a series on web programming and WebSockets with Go.
All right, everyone, welcome back. We are ready to go live with Ellie now to answer any and all questions you have. So Ellie, let me bring you back on. Turning on everything. Hello. Hi, welcome back. And first of all, thanks so much for your contribution. We're really happy to have you here at GoLab, even if it is virtually this year.
Which isn't quite the same as being in Florence, but it,
Yeah, not so much, not so much.
yeah.
So before we get to the questions, I wanted to ask if you had anything you wanted to say about the talk or about your participation in GoLab.
Well, I mean, to start with, there are links in the talk description for part 1 and part 2 of this, so it will make slightly more sense. And also a link to the GitHub, so you can actually see what I developed and the appalling things I did along the way to developing. Because it was only sort of like midweek that I decided to use JSON. Before that, it was a tab delimited text protocol, which might be interesting to people anyway. I mean, this is a strange way in which to give a talk. It's certainly not a way I naturally give a talk. I would have a lot more code normally. I hope it will have been relatively clear for people what was going on. And I will now answer literally any questions anybody's got about.
Yeah, we have some great ones that came in through the Q&A. We'll go ahead and answer those ones first and then move on to any others. So the first question comes from Frederick, who says, so is there a reason for the defer with the WS close, or was it just due to being used to writing it?
It was sort of a bit of yes. I mean, I tend to write them automatically. But then I was actually using it in the examples before we get into what was in today's session. And I guess I just forgot that I didn't need it until I was actually trying to describe the code. And I don't know, I mean, my eye always feels weird if I'm not seeing differs in those sort of circumstances. But then once I've chucked them away, I don't put them back in again. So,
all right.
It's,
okay.
It's weird letting somebody inside your head when you're around how you've actually written. It's very odd.
Yeah, definitely. And that goes for anything in life, for sure. All right. Next question here is, do you have any best practices for either connection loss or ping pong handling?
I'm not really I know I used that appalling phrase at one point in my talk. I'm not really a best practices person. I've been doing this I've been doing coding for almost 40 years, and I've been doing Go for just shy of 10. I mean, we're just a month away from that. And I tend to code a lot of this stuff by instinct, because I mostly work on proof of concepts for commercial system designs that I do in a particular field. And best practices, well, I've always been suspicious of the phrase, the concept, because of what it means over in the enterprise world. You go and look at enterprise Java bookshelves full of best practices on it, and it nearly always means turn off your brain and just copy some code. And
right. It doesn't allow for any real creativity or.
Exactly, and I like both the creativity side. I mean, I'm an arty type at heart, to be honest.
Sure.
But also, I like the idea that people should really understand their tools. And I think best practices often, when we're starting out, they can certainly help us stop doing stupid things we might otherwise do. But when we're starting out is when we need to do stupid things, or we're not going to really learn.
Exactly. You need to make mistakes to learn from them.
And by the time we're at the point that we can tell other people what best practices are, well, we've learned. But the reason we learned was we made those mistakes. And I'm always slightly suspicious of the cargo cult thing. I mean, half my life is over in the Ruby world, so I've watched the cargo cults around Rails for the last 16 years, and they come around every 3 or 4 years. There's a new one. So I'm always kind of suspicious. There are some. I mean, what I would say is always, when you're writing code paths for any kind of connection, opening and handling, you always want to assume it will fail when you're writing that code path. So you always want to fall back towards a safe state. Now, I've put none of that in this code. I mean, this is appalling. I'm using a single, I'm just saying, hi, you're the next person who's turned up. Oh, have the next slot in the array. And the reason I've done that is that I'd end up writing a hell of a lot of boilerplate, and then abstracting it away in a little DSL somewhere that I'd feel obliged to explain but it's totally not what the talk's about.
Okay, sure.
Tangent. But yes, in general, just always assume everything will fail. Never assume things succeed. And if you assume things fail, then you start to easily understand the error conditions that you ought to look out for and play with things. I mean, this is the first time I've ever given a talk in which I showed me playing with code, because I just don't, that's not how I want to give talks. I want to give talks where I've got the code down to the minimum and just talk about that. But the way in which I actually develop my code is I spend all the time interactively playing with it. I mean, what sucked me into Go, what turned me from a Rubyist looking to use a bit of Go to being a gopher who's a Rubyist, was the fact that I can do stuff as fast in Go interactively. Getting things to just Go run is just as fast as literally just loading a script in IRB, or even as quick as doing stuff with a bash script. And that back and forth, my best practice is actually that. My best practice is don't care about best practices, talk to your software more, play with it.
Yeah, there you go.
So that's that.
No, that's perfect. And it seems Preslav says here that's a nice way of thinking about best practices. So yes, it is useful to not be afraid of making mistakes and get creative a little bit.
Definitely never be afraid of making mistakes.
Yeah. You'll make a lot of them, and it's good. It's good learning practice. For sure. All right, so let's see. Oh, one more from the Q&A from Francesco. He says, a great talk, very interesting. What about high availability of WebSocket?
Oh, right. So, I mean, your main limitation with WebSockets, I mean, once you've got the WebSocket, you've got a genuine TCP socket, right? And from that point on, you can really think about them as we're just playing straight in the TCP stack. It has to get hijacked. I mean, I was going to show some code to actually show how to set one up from scratch, because I'm stuck when I gave the talk proposal. Firstly, I assumed I could do it all in a 40-minute talk, and that's proved very wrong. Ambitious. And normally I'd have just gone a lot faster, but it doesn't work quite like that with video, because you have to edit it and prepare it and render it, and there's so much time consuming. But I was originally going to show other WebSocket libraries, because there's about half a dozen of them for Go. But I decided to just go with the one that's actually in the X series of packages, because everybody's got access to it. And actually, for everything I do, it turns out it does it. I just want the socket, and after that, I don't want anybody telling me what I have to be doing to use the socket. I just want the socket. I just want to pump raw data over it. And at that point, I've just got a genuine socket, and that's fine. The trouble is, to broker that socket, I have to come in on port 80 or port 443. Now, the interesting, right, so I spend way too much time buried in network plumbing. So I'm trying to sort of throw all the crap away that I'm thinking about right now to answer the question directly. And the thing I think I care most about is I hit port 80, and now I've got a whole pile of processing lag while the headers are all checked. There's a round trip goes on in here with the web thing, and then you've got the socket, and then you can talk. So availability is going to mostly be limited by just how well your web server or your Nginx proxies or whatever you're using can do that. And I'm not an expert on any of that stuff, because by preference, I don't use web. Most of the things I write, I'd rather be using UDP packets for. And that's not, and I can't even do that with WebSocket, In your setup handler, you want as minimum amount of code as possible to actually perform that setup at your end. It's perfectly reasonable to give back something to the other end that allows them to go and slurp some more state out of band. I mean, it might well be, if I wanted to do this as a microservice network, I'd have a totally separate system for setting up the IDs. And I'd have a separate storage system, and I would probably have that distributed over a network at least. And I don't use cloud. We do internal stuff rather than cloud. But, if I was doing it with cloud, I might even be having separate cloud instances, cloud services providing those instances. Getting the balance of communication over those right is about lining everything up so that it's only one message here, one message there, one message there, and they can all send their own messages back to the source point. Well, we can't do that easily with the web setup bit. We can, once we've got a socket, we've got this direct point here. But what we can do with the web setup bit is we can define everything as this URL, this URL, this URL. Ajax, that end, knows how to slurp things. And at this end, we can have another system that coordinates our stuff at this end. And normally this is the point where I get out iPads and I start drawing diagrams all over. I'm a bit of a Luddite and I can't make that technology work at short notice.
It's fine.
but that's the thing. It's to always minimize the amount of traffic that you use to do a task. Try and make those as much single discrete messages as possible. Pack as much data into a message as you can. Because if a message fails, fine, you have to do the message again. You pay. So that in one of the previous two talks, I talk a little bit about network latency, only a little bit, but the thing to bear in mind. So I'm sat in a house in London, and I have a whole pile of Google servers not that far from me, within about 20 miles, that I can hit to do a Google search. And if I decide to ping those servers, on average, it takes 20 milliseconds for my ping round trip, right? Which is awful, to be honest. It really is quite lousy. It should be much faster than that. If I decide to go and ping Google's .com server, I'm looking at 200 milliseconds round trip normally, and sometimes a lot more than that. If the amount of work I do in my handler is low enough that I can serve everything back in a single response within that, and it takes 20 milliseconds round trip for that, then I, as a client, am happy. If I have to have two responses to do it, I might be introducing X number of different latencies at 20 milliseconds, or to the US, 200 milliseconds. From the server point of view, I need whatever I send out to not be computed on my box. It needs to be computed by other devices and just composited as quickly as possible in my root handler to send out. And that's really the trick. The trick is to offload as much at the back end to as many different services as possible that each can talk quickly about their one thing and composite it. And at the client end, to only have one message if you can get away with it. And if you can pull off those two, it doesn't actually matter whether your services fall over in between quite often, and you have to do reconnections, because you're still actually no worse off than people who are sending 4 or 5 messages backwards and forwards via web in the first place. Or if you can do HTTPS for your setup, though, chuck all that out the window. You've got a 12-step handshake instead of round trips. By the time you set up a secure sockets connection, the servers had loads of time to process stuff.
Sure.
So I mean, but that's what you have to think about, really. It's what the average time of getting a message in or out of the server is going to be, what kind of time slot I can afford compared to the number of things that want to connect, and making sure I do as little communication as possible, as accurately as possible, because then I don't have to do, I'm not going to have error handling. So that's
awesome.
I don't think that was as clear as it could have been, to be honest.
Oh, no, it's very insightful. Thanks. I think we've got, it looks like that's all of the questions from Q&A. We just had a couple casual ones in the normal chat. Let's see. Frederick also asks, what made you switch to Light IDE or Light IDE?
Oh, okay. So as I said, I'm a bit of a Luddite, and half my code editing actually happens in Nano, for which I actually spent the time to write myself a nice set of syntax highlighting. It's the only time I've ever bothered to do it for an editor. But it's the one thing you can guarantee is on every server, or is literally a static little binary installed on a server, so that's what I use a lot of the time. But I don't get on with heavyweight IDEs at all. And I don't really use Light IDE the way its developers intend. I mean, I could run Go code straight out of it and all of that. It's a proper IDE. And I literally just use it the same way I used to use TextMate. And I mostly switched from TextMate because it's a beautiful editor to use when coding Ruby. unfortunately stopped being a commercial project some years ago, which meant it went into a somewhat vague update cycle. And there were a few odd little bugs in there that sometimes caused me to gripe. I looked at all of the heavier weight IDEs, and I thought, well, yeah, I'm going to end up hitting function keys by accident when I'm typing and doing random things that are going to drive me nuts. I hate to be distracted when working. And then I fell across the Light IDE, and at the time I was looking for something that would show me how I could actually write cross-platform GUIs in Go, and I still haven't got around to learning that. That's a subject for a talk in the future. And I was quite impressed that it just worked on my Mac. It worked on Linux. It works in Windows. It even works nicely in Windows subsystem for Linux with a copy of an X server installed. And it's light and it's fast, and it's got the perfectly same search function, which I often find IDEs don't. And even though it drives me a little bit nuts when it's trying to do auto predictive text, and which is the thing I hate most in IDEs. It's like, that's not what I want to type. It's never enough to know that. But it's really light and it's fast, and I like the fact that it's single executable because it's Go. I mean, it's just, I think it's a poster child for what a Go cross-platform graphics app can be like, and I wish there were a lot more of them. So
for sure. Awesome. Well, it looks like I think that might be the last one. Okay, let's see if I just missed any. Okay, I think that's about it. And we are getting ready very soon for our next chat. So let's just say that was the last question here. And Ellie, I want to thank you again for coming to GoLab, even if it's virtually. It's a pleasure to have you here, and thank you so much for all of your insight. As a very experienced developer, I'm sure a lot of these younger folks have appreciated that.
Well, thanks very much for having me back again. It's my favorite conference, and it's a bit weird not being able to enjoy the lunches because, I mean, I've never known a conference quite so well catered. Hopefully next year we can all do it back in Florence again.
Crossing our fingers.
And in the meantime, the code base is in GitHub. I may at some point feel motivated to actually fix the bugs. I may not. If anybody else wants to fix the bugs, I'm happy to take pull requests. And also, if anybody's, once people have watched the other two talks as well, if there's any questions they've got, send them through to me. I'm easily findable on Twitter as Eleanor, which is the same as my GitHub handle, and I answer all questions. And also, I should probably give a plug for my book, because otherwise I don't make any money at all out of Go.
Go for it.
The only thing I make money out of is my book on LeanPub, because most Go I do as a hobby. So I've got a book on LeanPub called A Go Developer's Notebook. All the content from this will probably at Christmas get written up as a chapter, because I haven't really got any spare time till then. And at which point I will probably extend it out with some other weirdness. So
fantastic. We're looking forward to it. Thank you. Awesome. All right. Well, I hope you enjoy the rest of GoLab. Again, thanks so much for being here, Ellie. And hopefully we get to see you next year in person. Crossing our fingers for that. Thanks. All right. We'll see you around.
Take care.
Thanks. All right, everyone. Hopefully you enjoyed that. I know I did. I just want to remind you all that you can rate this talk on the agenda page of GoLab. So next we've got, in about 10 minutes, the next talk of the day, which is diving into the Go toolchain to obfuscate, that's a hard word for me as a native English speaker, to obfuscate builds by Daniel Marti. So we will see you in the next session for that. Bye.